Welcome to the third video in week 3. We have here now 15b in the textbook, and this is about the chain rule. The chain rule has to do with when we have a function inside another function. And we know from grade 11 that function inside of another function, we could call that a composite function. So if we think of composite functions, we can use them, can be used to represent more complicated functions. So for example, if we have y equals x squared plus 3x, which is all to the power of 4, we could actually say, so could be written as y equals u to the power of 4, where u is x squared plus 3x. Okay, or using composite function notation, we could say f of g of x is our function. Same function as up above, where f of x is x to the power of 4, and g of x is x squared plus 3x. So we've always seen these questions the other way around. We've seen them as given f of x is x to the power of 4, and given g of x is x squared plus 3x. Tell me what f of g of x is, and we would end up with this function here. Okay, we can actually differentiate these functions, and we have a special rule called the chain rule that helps us differentiate these functions. Okay, the chain rule. If y equals g of u, where u is actually equal to f of x. Okay, you can see that if we substituted our f of x where the u is, we would get g of f of x here. Okay? Then the derivative, dy dx, is actually equal to the derivative, dy du, multiplied by the derivative, du dx. And just using algebra here, you can see that this would be true. If I multiplied these two fractions together, the du divided by the du equals 1, and those would cancel. And so this indeed does equal dy dx. Okay, so written another way, we could say y is equal to f of x, but that f of x then has a power of n on it. Okay, and then if we take the derivative, we need to bring down that n in front. Okay, and we would then need to decrease that exponent by 1. But this isn't all we have to do when we're doing the chain rule. So that's the first part of the chain rule. Second part of the chain rule is then we need to also multiply that by the derivative of that inside function. Okay, so here we're basically looking at two functions, the function f and then the entire function here, Okay, the function f has another function attached to it. In order to take the derivative of that, we take the derivative of this big function, which was multiplying the coefficient here of 1 by our exponent here. That gave us the n. Decrease that exponent by 1, but then multiply this entire thing by the derivative of the inside function. Okay, so then the derivative of that inside function. This is what the chain rule is. All right, you're going to need to remember that rule. So let's look at an example. We have y equals x squared plus 3x to the power of 4. All right. So one way of making sure that we keep track of what's going on here, we could say, let's let u equal x squared plus 3x. Okay. Therefore, we can take the derivative of du dx. It would be 2x plus 3. That would also mean over here that our function is y equals u to the power of 4, because we said here that u is equal to this. Okay, so I can then substitute x squared plus 3x for the u. We can take the derivative of dy du, and that would be 4u cubed. Okay. So we could think of this as step 1, we could think of this as step 2, and the third and final step would be take the derivative of the entire function, which is the derivative dy du multiplied by the derivative du dx. Dy du is this one, 4u cubed. Du dx is this one, 2x plus 3. But u, remember, is equal to this guy up here again, x squared plus 3x. We can't keep a u in our final answer. There's no u in our original question, so we can't keep a u in our final answer. So 4, replace the u by x squared plus 3x. It's all cubed, and then 2x plus 3. And we can leave our solution like this.